Let me go ahead and hit the little. Let me hit the little turn on live captions. Okay, the reason I'm showing you this is because I want to show you or start getting you to think about the squeeze theorem and the limits. Now, I'm going to get into this in just a minute, but I want you to start thinking about this is what you call the squeeze theorem. Basically, if you are approaching x from the left and the right, then your y is approaching a y from the top and the bottom. And the blue and the yellow, the blue on the left will be the negative side. The blue on the right would be the positive side. And if you come in, so like if you're approaching A, and A is equal to 2, and the limit approaches 2, then think of your half a step to a half a step to a half a step to a half a step. You get within a hairline of A, then you are approaching 1.5 on your Y. Now that's how you answer a limit. In other words, when you are asking for a limit, they are asking you what Y are you approaching. Okay, so in this case, I wish I could write on the screen, but I can't. You would put limit as x approaches 2. What is the limit? The limit is 1.5. Now, this is your basic type question that you will see on the test. Okay? There's about 4 different types of limit questions in, I think this is chapter 2 pretty much. There's 4 different types. There's graphing, continuity, or does the limit exist, does the limit not exist? 2 type graphing, and then there's about 3 type of algebraic equations. So this represents the basic, this represents the basic. Let's go ahead and move to 5.
Now, is the squeeze theorem the same as epsilon delta thing?
Yes.
Or whatever? Okay.
In fact, up there to the left, it's epsilon. See the little backwards 3? That's epsilon.
Okay.
So you see it in first variable calculus also. And now I can't get it to move. I'm trying to get it to. I went to, darn it. Well, anyway, the limit as x approaches 5 is 2.25. So I want you to get that down as a basic type graph. You'll get a couple of these on my test. I'll put a graph and I'll put a function, and it'll ask you what is the limit, and all you're looking for is the y. Okay. Here's another example. This example, if I'm approaching from the left, if I'm approaching A, if I'm approaching A from the left, then I'm approaching 3. If I'm approaching A from the right, I'm approaching 4. Now I need you to highlight that 3 and 4. I want you to draw this in your notes or take a picture of it. If the limits, and write this down, if the limits are not equal, then the limit does not exist. So 3 does not equal 4. So this limit does not exist. So you need to write that down. And we're going to go through a couple of these, and you'll see some on your homework. I'm going to ask you maybe 2 or 3 of each question. I'll ask you a couple of graphing questions. I'm going to ask you a couple of algebraic limits. So you're talking about 6, you're talking about 8 questions. 2 graphing questions, and then 6 of the algebraic questions that we're going to go over today. Okay, so if you're approaching from the left and the right, and they're not equal, then your limit does not exist. And if you go to infinity, the limit does not exist, and we'll get to that later. So there's a good example of the squeeze theorem where you don't have a limit. In the previous question, I got two laptops. I'm trying to use one mouse for both of them. In this question, I wish I could get it to work. I must have messed it up. Yeah, it's not going to do it. See if I can get it to. No. Oh, there we go. Okay, here is a basic. This is one of the first one. As x approaches 5, what is the limit? 2.25. That's it right there. That's a question right there on the test. I'll give you a function, and I'll ask you as you approach 5, what is the limit? And you'll say 2.25. And you'll be able to tell. All you got to have is a straight edge and just draw a point. Say again?
How do we go about evaluating this stuff, though?
Evaluating is the algebraic part.
Yeah.
Okay, we'll get to that in just a minute. Right now, we're not evaluating. What we're doing now is we're looking at a graph, and you're telling me where it is approaching. Okay. Where it's approaching, and it's only approaching here at 2.25. If I move A, let me move him again. Let's move him to 3. Okay. Then I'm approaching 3. What's my limit? 1.75. Okay, now the reason I like to show these graphs first is it's because it makes you visually think out of the what? Think out of the box, Hubert. That's right. Because you're approaching that A from two different sides. And when you approach the A from two different sides, you approach the Y from the top and the bottom. Now, what's the difference in that graph and this graph? Well, this one's discontinuous. Okay, and you can do it right there. See, I'm approaching A from the left and the right, just like I was in the previous problem. But this one is not continuous. So therefore, 3 does not equal 4. Therefore, there is no limit. So you would say here, limit does not exist.
So for a graph to have a limit, does it have to be a continuous line?
Not necessarily. I can approach the same Y on a discontinuous and it still be a limit. And we'll get into that. We'll get into that later. Okay.
Like it can have a hole and be
Yes.
continuous, or not. I mean, be a limit.
Yes, and that's why you need to hold off until we get to the actual examples, and you'll start to answer these questions. Ms. Patel, or Mr. Patel, I'm sorry. I can't tell what Hina is. I'm sorry. What about the domain and range in both continuous and limit functions? Well, the range here, the domain, is negative infinity to 3 parentheses, and then from 3 to positive infinity. That's your domain. Now you've got 2 open circles at 3. So 3 does not exist. It's non-inclusive. Okay? And the range would be negative infinity to 3. And then of course you would have a range. There would be a gap in the range basically from 0 to 3. And then you would have from 4, well, you basically would go to, what is that, max? 5? I think the max is 5. Then 5 to negative infinity. But you would have a gap between 3 and 4, basically. So and you would go as far to 5. So you could say 5, the range, and I'm not going to ask you the range on this, but you would say basically the range would be from 5 to negative infinity, but x does not exist between 3 and 4, or y does not exist between 3 and 4. Okay, does that help? Okay.
So
Thank you for helping me out with that, Hina, because I thought it was feminine, but I wasn't sure. Okay, I'm just a dumb country boy, so I'm having to learn some names. All right, who else had a question?
So for example, on that graph right there, since 3 is not included, if you were to move a to 2, like a equals 2, then it would have a limit, right? Because is that how that works?
Yes. Yeah, if you moved a to 2, then the limit would be like 2. And you
Yeah.
approach from left to right, then the limit would be 2. Yes.
Yeah. Okay.
Okay. But it all depends on the question. That's why you can't ask what if questions with this question, because one, this is discontinuous because it's got a break in it, but it has two limits that are not equal to each other, so therefore the limit does not exist. And you can't say, what if, because technically this is only one problem. Okay. We can change it. Let's go to another one. Here is, I'm trying to use the other mouse, I'm sorry. Here is when you have, let's see, continuous at F, no, continuous, yeah, there we go. And you see, yeah. This one, a function is continuous at point A if the function at A exists and the limit exists from the left and the right. So in this case, and this one can be, and I don't want to get into this one too much because I need to get to the algebraic, but if you move, like the more you move these around, like I can make that one right there, just about right there on top. Okay, now, I think it was Mr. Anderson. Who was that just asked that last question? I can't see. I don't have y'all up. And who was that asked that last question?
That was me. That was Anderson.
Okay. Okay, Mr. Anderson. What is the limit as A approaches 3?
4. Right?
As A approaches 3, what is from the left and the right? What's happening?
It's at 1, isn't it?
It's going to 1. Now, what is f of 3? F of 3 is equal to 4.
Okay.
Because you can't, first of all, do you see the open circle right there at 1?
Yeah.
So therefore you can't say f of 3 is equal to 1. F of 3 is equal to 4 because you got a solid dot up there. Okay? Now, if you do the limit as x approaches 3 from the left and the right, then you are approaching 1.
Okay.
It depends. F of 3 is exact. F limit 3 is approaching. So approaching doesn't have anything to do with that purple dot up there.
Okay.
Approaching has to do, think of a railroad track. When you're talking about a limit, you're talking about a railroad track. If you're talking about F of, then you're talking about throwing a dart at a dartboard. Okay? F of, if I throw it at 3, I'm going to get hit 4. But if I'm approaching train tracks, then that train is approaching 1.
Okay.
So you can move this up and down, but I'm just going to you got to be able to read the graph. And right now, I just want you to be able to read the graph. Here's an example of the limit does not exist. Okay? And I don't want them, I want them to come in. There we go. Well, you can do it that way also. As I'm approaching from the left, well, where is it? There. as I approach from the left, from the right, I'm approaching from the right. I'm not coming from the right. It hits that 0 and it doesn't touch. Okay. When you have an infinity, when you have infinity and infinity, the limit does not exist. Okay. When you have a vertical asymptote, the limit does not exist. So as I'm approaching 0 from the left and the right, what is my limit? Tell me a number I hit for y. As I'm approaching, I'm not approaching anything. Give me a number on this line that I'm approaching for y. If I'm coming from the right here, and I come to x is equal to 0, give me a y that I hit. You can't, because it's not touching y. Okay, well, let's go from the left. Left, I'm coming this way, and I approach 0. As I approach 0, what number for y am I touching?
9.
You're not touching any. So when you have infinity as your limit, the limit does not exist. Think of it like this. Anybody in here for a $100 bill, I'll give you a $100 bill right now. Give me the number that signifies infinity. I'm waiting.
Loaded question.
Exactly.
Knocked out
right.
8.
It's a loaded question, just like
That's
right
worth
now.
50, isn't it?
Oh, be quiet. You just want money. Okay. The whole thing here is, can you give me a y at x is equal to 0? Yes or no?
No.
Undefined.
The answer is no. You cannot. At x is equal to 0, you can't say y is equal to 4 because it doesn't touch 4. You can't tell me y is equal to 8 because it doesn't touch 8. Now, you could say, well, it sure does look like it touches 8. Well, that's your redneck disorder. It doesn't. Well, it touches -5. No, it doesn't. Does it ever touch the y-axis? Yes or no? Never. And if you look, x is equal to -15,000. It just keeps on going. Now, there is a horizontal asymptote of +2, but that's a different animal. We're talking about horizontal asymptote. Okay. Oh, whatever. Sideways 8. Okay. Whatever. You just want money. Okay. Does everybody see what I'm trying to get you to see as far as the graph? When you're looking at a graph with limits, you have to, what's that word? You have to think a little bit. Okay? So right now, I'm going to close this out. And now I'm going to stop the recording, if I can find y'all on this little laptop. And I'm sorry about this, but I'm going to stop the recording, and I'm going to call y'all back in on my other laptop, okay? Everybody understand me?
Yep.
I hope so.